10.5, polar coordinates and polar graphs. No calculus in this section. Equations relating polar and Cartesian. Okay, so how are they related? If you forget all this stuff, you can just start by making a unit circle, making our little hypotenuse there, which is the radius of our unit circle. Call this my x and that my y, and our angle theta. So you can generate all of the relationships you need just from that one. If you solve for x, x is going to be r cosine theta. If you set up cosine of theta equals x over that, solve for x, it's going to be r cosine theta. Y is going to be r sine theta. Pythagorean theorem, x squared plus y squared equals r squared. And then the tangent of theta equals opposite over adjacent, or just y over x. So those are the four equations that you would use to relate polar and Cartesian coordinates. So Cartesian is just x comma y. It's what we almost always do. I think if you had time with Mr. Frisbee, you did polar coordinates. Normally it's designed to be taught in pre-calc. I don't know if you did. Pardon me?
We ended on limits.
Ended on limits. Well, it would be before that, but he might have skipped it to get the limits. I don't know.
No, we did it. I remember.
It sounds familiar.
Okay.
There was the I and the J.
Yeah, I do remember that. We did that.
That's not this.
Oh, S equals R
On there
theta.
somewhere.
S
Oh,
equals
really?
R theta. Yeah,
So we
did
did
that.
it.
Wait, can you explain?
No.
S equals R theta.
You did that?
Yeah.
Okay.
What's the
Okay, so I'll talk about it. Try graph on your calc. Okay, so let's go ahead and, just for funsies,
Oh, wait. Never read that out.
go to mode and go to function is where we usually are. Parametric, we've been there before. Sequential or sequence is when all your x's are n's. You could do sequences that way. But we're going to do polar. So we'll go to polar, and we have a contest for two starburst for the best polar graph. You've got
Color starbursts.
your choice. You have 4 minutes. Go.
What does that even mean?
Okay, so some problems and graphs are better represented with Cartesian, some are better represented with polar. So the polar ones, if I just typed in r equals 2, that gives me all points of the radius of 2. If I graph it, it's just a circle. So that would be r equals 2. If I did Cartesian equation, that would be represented with the radius of 2 would be x squared plus y squared equals 4. So it would be easier to be represented with polar equations. So it's an option to represent functions in either polar or Cartesian. They're related, or for if it was a line, lines are much better suited for Cartesian equation rather than polar coordinates. So as I said before, they're related. These are 4 problems that do relate x's and thetas and y's and thetas. So on the bottom here, I'm asking you to take a polar equation and see if you can convert it to the Cartesian. Here's a Cartesian to polar, and here's another polar to Cartesian. All right, so for the sake of time, I'm just going to go through these. What do we do here in the first one?
You took the R out and it's 2 R's.
So think of it as an r attached to the cosine and an r attached to the sine. And r cosine is just x, and r times sine is y equals 4. So basically one step and we get our answer. What about this one?
You square the R cosine theta and you square the R sine theta.
Oh, so you change your x to be r cosine theta and your y to be r sine theta, and you get r squared cosine squared theta minus r squared sine squared theta. All right, again, pretty straightforward. What about this one?
You get the square root of x squared plus, and then you gotta like simplify that.
So this is 1 plus 2x, but what about the r?
That's why I said the square root of x squared plus y squared.
Oh, so you said r is the square root of x squared plus y squared equals 1 plus 2x, is what you said.
Yep. And then you square that, and then you square that.
Square both sides?
Yep.
Okay, so we get x squared plus y squared equals 1 plus 2x squared. And expand that. Move everything over and you're done. Okay, so anybody do it a little bit differently, the third one? Or maybe you didn't have time to get there. Okay, so I would have squared it right away, both sides, and would have gotten the same answer. So it doesn't matter if you converted this r to this, or I could have squared both sides right away, and I would have got the same. So, personal preference. All right, so polar style. Polar coordinates is always r comma theta, where r is the directed distance from, it's the pole to P. The pole is the origin, but in polar it's not really the you think of it as the origin, but the graph could go through the origin multiple times, so it's called the pole, P-O-L-E. So r is the distance from the pole to the point, and theta is the directed angle from the initial ray. So this point right there, P, is r, because it's r units from the pole, and theta is the angle it's made from the initial ray.
Is the initial ray just the x-axis?
Yep.
Okay.
But yeah, I can't call it the x-axis because it's not the x-axis anymore, but yeah, think of it as the x-axis. Okay, so plot the points with the given polar coordinates and find their Cartesian coordinates. So I have square root of 8, comma, 3 pi over 4. So remember, this is r, comma, theta. So the distance from the pole is square root of 8, and our angle is 3 pi over 4. So 3 pi over 4 is 135 degrees right over here. And our distance is square root of 8. So A, it's along the line where this is 3 pi over 4, and it's square root of 8 units from the pole right there. So if it's square root of 8 units, and if this is 3 pi over 4, you could use special right triangles and find out that each leg is 2 in magnitude, so it's negative 2, comma, 2. The Cartesian point that represents this polar point is negative 2, comma, 2. Okay, another way of doing the same thing, if you know that that's r and that's theta, you can just find x and y. Remember, x is r cosine theta, y is r sine theta, by just plugging or making it r cosine theta. So it's that is my r cosine of 3 pi over 4, and that all gives me negative 2. Do the same thing for y, and that gives me 2. So however you want to think of it, you'll get the same answer, negative 2, 2 for both of them. If it's negative, we go to 4 pi over 3, which is down here. The fact that r is negative means that it's reflected through the pole the other way. So it goes across. So it's going to have a distance of 4, but it's going to be down in the quadrant 1 because that's negative. So 4 pi over 3 is right down here. It's negative 4, so it's going to be up here. So this is what the triangle is going to look like with a 4. And since that's 60-degree reference, that's going to be 2, 2 square root of 3. We can.
Explain the whole negative thing again.
Yep. So why don't I just plot the point negative 3, comma, pi. So on this axis, negative 3, comma, pi. Well, pi is right here, right? That's pi. and that's 3, 1, 2, 3, but it's negative, so it's actually going to be right over here. It gets shot through the pole the other side.
Wait, why is it like that? Wait, where is pi?
Pi is 180 degrees. So if that was 3 comma pi, it would be right here. This point right there is 3 comma pi, because it's 3 units from the pole, and pi is the degree from the initial.
Oh,
Since
so
it's
negative doesn't actually matter.
The negative just shoots it through and it comes right out here. This is negative 3 comma pi.
Do you have to do the angle first then?
No.
Or like,
No,
Pi
you,
and negative 3 comma pi aren't the same?
what did you say?
3 pi and negative 3 pi are not the same?
Correct. 3 pi is right there, negative 3 pi is right there.
But if, wait, what? That's not even pi.
so like, if you're going to pi, you start at pi and then you do the negative, is what I'm saying. Like,
Yeah,
you do
now
pi
I understand why you asked that. Yeah, you can do that, yeah.
Okay. I still don't understand how, that's 0, not pi.
But the negative r, the directed distance from the pole, goes the opposite way. So if the directed distance was 3, we would go 1, 2, 3, but it's a negative 3, so it goes backwards 1, 2, 3. Since it's a negative.
That's negative though, that way.
Distance from the pole, so don't think of r as either positive or negative. It's the directed distance.
Isn't the pole the origin?
Yep.
So wouldn't it go backwards, negative 1, negative 2, negative 3?
But we're in like unit circle.
So I want you to plot a couple points. Okay, you ready? Plot 2 comma pi over 2. Plot that point.
Isn't that what's already done there?
Nope.
Or no? Oh wait, it'll go right there. So like on the y-axis at the top.
Yep. So what's the Cartesian equation or Cartesian point for this one? What comma what? In like an xy plane.
0, 2.
0 comma 2. Very good. It goes right up here, and there's 2 comma pi over 2, which is the same as 0 comma 2. What about if that were negative 2 pi over 2? That would be right down here.
Yeah. Yeah, because negative is down and positive is up, and then negative is left and positive is right.
But
You're using the wrong logic, though.
just flip it and say that just flip.
Yeah, but I wouldn't flip that, because if it's positive, it goes up.
But that's why you.
Okay, so some more. Here's another one. C, negative 2 to go to pi over 2. It's right down here. Oh, pi over 2 is right up here. So if it was 2 comma pi over 2, it would be right there. Since it's negative 2, we go down to there. We flip it through the origin. So that's C. The Cartesian corresponding point would be 0 comma negative 2. All right, so one last thing in this section we'll do is page 556, number example 5. So we have a polar equation for the circle this. Oh, find a polar equation. All right, so first thing I would do is expand the y minus 3 squared. So y minus 3 is quantity squared. You get this. And you see x squared plus y squared is, that's our r squared. Subtract 9 from each side, that goes away. And then it's minus 6y is just minus 6r sine theta. The book didn't show this part, but I wrote it in pencil here. So that's kind of just algebra. I factored out an r here. So set each of those equal to 0. I get r equals 0 and r minus 6 sine theta equals 0. Two different polar equations representing this circle with a center at 0 comma 3 with a radius of 3. Now, the answer would just be r equals 6 sine theta. We do not need to include r equals 0. What is r equals 0 if you can think about it? Yeah, it's just the pole. All points that have a radius of 0 is just a dot right there, or dot right there. R minus 6 sine theta, or basically r minus 6 sine theta equals 0, so it's r equals 6 sine theta. That is this circle with the center at 0, comma 3 with a radius of 3. That circle goes through the pole, so it would be redundant to include r equals 0 and this one, because r equals 0 is a part of it. So then you can just say that this would be the best equation, polar equation, to represent that Cartesian circle.
Is there an instance where that would, I was gonna say, if it doesn't go through the pole, then that would make sense.
So if it doesn't go through this other, like r equals 0 or whatever, I don't know that there would ever be that instance, but it wouldn't really make sense. But in theory, you would include a dot other than whatever the graph is, which isn't going to happen. Okay, so you'll see that using polar, everything is symmetrical. Like if you have a circle, you've got different flowers, cardioids, you can see all sorts of different symmetry. Limasomes, there's all different kinds of polar pictures, and you'll see how they all kind of will continue, and sometimes you'll draw it and it'll just keep drawing the same thing over and over again, or it might make a loop, another loop, another loop, another. So a lot of the 10.6, there's going to be a whole lot more application of this stuff. 10.5 is just kind of introducing you again to the polar coordinate system.